Right. Hi, everyone. Welcome to today's webinar. Very excited to have Marcio joining me today. Marcio is a application engineer for one of our Geomagic partners based out of the Bay Area, Indicate Technologies. Today he is going to be focusing on a very interesting workflow. I'm sure you've seen the reason that you're here, why you signed up to this webinar today. He's going to be using the Artec Leo and Geomagic Design X to reverse engineer and 3D print the Golden Gate Bridge monument. A few housekeeping bits today before we start, before I pass over to Marcio for the interesting bit. If you have any questions as we run through this webinar, we have set aside 15-20 minutes at the end of the session to answer any questions that you might have. So please drop those questions in the Q&A box in the GoToWebinar control panel, and we will we'll host those and get Marcio to answer your questions right at the very end. Marcio's presentation will last around 30 to 40 minutes, so we'll have plenty of time to answer your questions right at the end. So without further ado, I'll pass over to you, Marcio. Take it away.
Thank you, Guy. Well, thank you for joining us today, this morning, here for me in Pacific Northwest. Thank you for coming, and I will show the workflow and everything what I did. I will talk a little bit about Indicate Technologies. We are Octone Geomagic partners. We are on the market a little bit more than 20 years now. We work with metrology, 3D printers, and 3D scanners. We are located in Bay Area and also in Vancouver, Washington, where I am located. But I'm everywhere. I'm a senior application engineer. I'm working with Geomagic more than 25 years now. My background, I came from Brazil. I used to be an 3D System Geomagic partner and an Artec partner in Brazil. Then I moved to the United States 7 years ago, started to work with Indicate, and then the rest is history, right? I'm doing that for more time than I can remember now. Well, let's just cut the small talk and go direct to the workflow and what I did and why I did it, okay? Let me bring Design X for my screen. Okay, Golden Gate Bridge is one of Indicate customers. They have Design X, and also they have one Artec Leo for their maintenance and their use. I'm there everywhere. It's like I'm all the time. When I'm around San Francisco, I visit, and they have this monument there. And I always thought in 3D scan and 3D print. It's a small version to have in home, something from the bridge. When I had a chance, I walked to this spot. It's around like half mile from the tall area on the bridge. I was with the Leo and the backpack, the Artec backpack. I walked to this spot and I start to scan the monument. I will play a video myself doing that, just for you guys to have an idea how it was done. This video is on YouTube. Maybe a few of you saw. If not, you can easily find on Octone web page, YouTube page, or on Marcio's Corner page. Let me play here, and then I will coming back for the Design X and show the workflow how I did. Okay, let me share here the video. Okay. a very short video just to show the workflow. And now let's show the results and do the workflow in Design X. Okay, here's the mesh result from Artec Leo. Okay, I will hide here my reference planes for now, and you can see everything. And then you can see that from inside, I wasn't able to full 3D scan. There is no space enough to place the scanner inside. And then I have a lot of holes, right? This is a problem to 3D print. Then I can close the holes, try to do my best inside of Artec Studio and generate a watertight model that will be able to 3D print. But I want to have a close to perfection file now that I can really print. And then I realize that if I do the reverse engineer of this monument, will also show how good Design X is. Most of my customers don't have the need of doing these very organic shapes. But if you need to do it, what software will do that for you in an amazing way? Then Design X is perfect for that. Okay, how I did that? Okay, well, here we are to discuss now. The first thing that I did, I create regions. Then the software will recognize common areas like planes, cylinders, spheres, and everything else will be a free-form shape. And our result is something like that, a patchwork with a lot of areas that will be, you can see here, a plane, free-form plane. And what I want to have is a unique area here where I can create my surface on this side and then the other side. But when I generate these regions, due to the nature of the monument, have a lot of patches, right? That we can easily come here in regions and we can select like several ones like this, and then we can merge together and have a single one that will be easy for me to select and create my surface, right? I'm doing that real time, right? That's how I want to show the speed, how it works, and then I can keep going and adding more and more to save our time and your time. One side I did before this webinar, but I want to be full transparent and show, look, I need to do all these steps. Or if you prefer, and there's several ways to do the same thing, you can not create the regions automatic, how I did, and you can come here, select a tool like, let's just pick here and do something like that. Select one area and then ask to insert a specific region, and then you can paint all with a brush, and now we have one single one. Then it's up to you how you want to do that, right? I did automatic, and then I combine, and I don't need to combine. I can, when I will extract that, and I'll be showing later. But let's do this surface, right? here is all the power of the software. Okay, I have the regions. I will change here for model, and we have a few options. The option that I will use is the loft, but I will use loft wizard. Then the software will guide me through all the steps, and I don't need to you know, it's like play with numbers, this or not. The software will do that for me and then save me a lot of time. It's what I want to do, but I don't want the sections in this way because I know that in this area here at the monument will not be good in this orientation. Then what I will do is rotate here. Let's put in this angle, and then I will extend. I want the surface bigger, right? This I will do 20 sections. We have some controls here, and I want a 3D sketch. Can be just a mesh sketch. I want a 3D sketch, but you can play with what makes more sense for your project. And I will just hit a button for next. The software will extract 20 sections on this region that I select, okay? And sometimes fail. I think that I just need to be a little bit more closer here. Once again, I'm doing that real time, showing a real scenario now, and then things can happen a little bit different. And why not? In the webinar and demonstrations is when these things happen, right? Okay. As you can see, the software generates 20 sections, including ones outside, and then we will have a good amount of surface that I can cut later. And placing 379 points each, I will change that for 200 just to have a little bit more smooth surface. And then the software will probably will be hard to see the difference, but you can see less points here, and I will accept, okay? Now the software is finishing this step, and then we will have one single surface here that we can start to create the thickness and extract the first side. Okay, let me hide the mesh. Here is the surface, okay? And you can see all the bumps, and I have this thing here, and this is a problem. What is that? Let's check the mesh. Oh, this is one rabbit, okay? And probably I select that, my mistake. How I will fix that? Well, I don't want to come here, remove that area. What I will do is on the 3D sketch that we create, the loft wizard generate to us, I will double click, and then I will have access to all the sections. And then what I will do here, I will give a big zoom here. We have a few points, and I will select these points. Only the points you don't want to select. And I will hit delete button here. Okay, I delete these points, 4 points, and I think that will be enough. Okay, and then let's leave addition. And as you can see, I don't need to generate surface anything. Always there. And then we don't have the bump anymore. All right, let's bring the mesh again. And I will create like a heat map just to see how close to the original is. Everything that is green is inside plus minus 0.1 millimeter. Okay, this is around 6 feet tall monument. I'm doing real size here. I just scale the end result when I 3D print, and we are good to go. I'm happy with the result. Okay, what I need to do now to create our first sheet metal of this monument is we need to do like a thickness, right? Let's do an offset of this surface here. Other side, this is ½ inch, 12.7 millimeters. I do everything in metric. Once again, from Brazil, we learn in metrics. Then the imperial system, it's a little more challenge to me. I'm sorry about that, but the software is capable. You can use metric or imperial system, and you change the units for the project or for whatever you want to do. Okay, then I give the offset. Okay, now we have two surfaces here, and I will hide this for now. And now I need to create this contour here. I will do an extrusion and cut, and then we will have our first part here. How I will do that? I will bring back my reference planes, top, right, front, and right, and then I will do a sketch, a mesh sketch. I will extract information from the mesh. I want to do on this plane here, and I will move more close to the plane. But what I want to do here is I will do only on a specific region, and then I will say limit to the region, and then I will select this region to avoid select other things, right? And then I will do a silhouette. I think 200 will be enough, and I will explain as soon finish. What I'm doing here is creating this volume, and everything that is inside of this volume, we will extract the maximum, the boundaries, the maximum area, right? Then it'll be easy for me to do a better job, right? Okay, I'm happy with that. Okay. And here we can create our lines. Oh, sorry about that. So double click here, double click here. I will do like one curve here just to, oh, and you can hide or show the mesh. Then you have a better understanding what I'm doing. Okay. Just want to have a little bit more control. Okay. What I will do here now is just extend with a trim, corner trim, here, here. These four corners. Perfect. Okay. I can leave this. And then I will bring my surfaces here. I will hide my reference planes again, just to be easy to understand. I will extrude that information until I pass out the surface. Okay. See here that I need to do a little bit more, and then it's easy. I can extend this surface maybe a little bit more, 100. and this side too. Perfect. And I will do the other one too. Okay, it's enough. Okay, that solid model I will cut with these two surfaces. Let me select these two. The target is this. And now I will select what I want to keep. In this case, just the thickness. And then I don't want the surface anymore. And then we have our first sheet metal, right? The first part of the monument is here. Okay, we have a solid with thickness, and then you can see here, probably should do a better design of my sketch. And I did that when I create all this reverse engineer. Here is just to show the workflow. Okay, and I will do one more, then I will go for the next step, that is do the Revits, because I basically did all this design, all this reverse engineer with a few sections using Loft Wizard. Okay, let's do it again here. Now I want to do here, and as you can see, I can pick this other area too. Don't need to be together, like how I did on the first one, where I connected all the regions. I don't need, I can select. It's different ways of doing the same thing, and you can decide what works better for you. I will do the same orientation as I did the other one. Let me fill here with the right size. Let us extend here a little bit. But here I don't need 20 sections. I think that is too much. There's not a lot of details. Let's change for 10. 10 is a little bit better. Size is good. Let go, see if we work. Okay. Fail. Let's do a little bit smaller. Let's see if it will work now. Okay, what's going on here? Okay, just because I'm doing a webinar, this playing with me a little bit. Let's put more here just to see if I solve. I did all these steps several times before and never fail. It is what it is, right? Fail, we're doing. Okay. Fail again. I will just jump. Okay, let's see if I just move one step back here. See if I will have the same problem. And I'm sorry about that. Usually it's pretty straightforward. It's just because I'm doing a webinar. Okay, and that's how I like to show people things. We deliver training, support, demonstration. That's our goal as a company. We sell scanners, printers, and then we deliver everything, and we give support in everything. And then I like to show real things and not like no videos or PowerPoint showing how good is the software, and you can see that probably I select something else on that side. That's fine. Okay. Surface is here. Now extract there. We have all these tabs with surface, solids, meshes, and we can hide or show. We don't need to show our solid here. But then I create this other surface here. What I will do here now is give an offset, has the same thickness of the previous one. That is ½ inch. Okay. Now I will do something a little bit different to extract that contour. What I will do here is I will show my reference planes, but now I will generate a plane here. Okay, and I ask to extract a best fit. Then I have this plane, and now I will do a sketch, a mesh sketch on that plane only, and I can change the size of my plane here to be only under what I want. And now I will do a silhouette of what, 80 millimeters, I think will be enough. Can be less. Okay, can be even less. What I want to do is pick only information on that area. Perfect. Okay, let me hide the mesh. That's what I want. And I can create lines, fillets, everything, or I can go for Alt Sketch, and I will be selecting everything that I want. Okay, and okay, we need to connect that area. And you can create everything, or you can decide the software to tell you, let's do a fillet here, and we'll put all the restrictions like tangent, parallel, all this. This is an artistic part. This is a monument. Then we have a little bit of, we don't need to be so accurate, even that we can. And I'm also just want to show as much as I can here, and then you guys can understand what can be done with the software, all the power of the software. I think that all is connected. Let's bring the surface back. We don't need these reference planes again. Okay, I will do that, and then I will do an opposite direction too. Right, very good. Let's bring the solid here. Perfect. And now I will do the same strategy. I will cut that solid part with my two surface, select what I want. It's just the middle. Perfect. No need to have surface again. Mesh. And now we have two parts, right? And I keep going until I finish all the monument. Okay. Once again, I did this loft wizard for most of the part, for most of the monument. And for just a few details, I did something a little bit different. And one of the things that I did different was, let's bring the mesh back, creating the rivets, right? There is hundreds of on this part, right? inside and outside. Okay, what I did here in Solid was Solid primitive, and the software can understand if it's a sphere, we will extract, but most of it, the software is telling me that is a free form shape. Then I want to extract a specific shape, a sphere shape, and then I will click this area here and ask to create one sphere, right? I will hide the mesh, and then you can see we have the Revit, and I can keep going, select this one and create, select this one and create, and select this one and create, and keep going. Okay, what happened here, everything looks good. Let's pick something, this one will be different. Everything looks good, right? But what happened is we have no control on the size of the Revit, on the size, on the diameter of the sphere. We are selecting one area and doing a best fit, right? Once again, maybe the difference of the size will not be a huge thing. I will print a small version of that, but I want to do that as best as I can. Then what I did in this case was, let me open here, and I will just hide these ones. I like that one. Okay. What I did is I create one, I like the size, and I copy for the other ones, right? How I did that? We have here transform body. I want the sphere. I want to duplicate. Next step. Okay. And now what I will do is I will copy that, align to scan, and then I will start to pick areas like this area here, and then I will start to have the same sphere for all. Okay, a few ones I will need to do moving a little bit, changing location a little bit, and now we have the same diameter for all, and a few areas inside I will not able to scan, and then I will just find the best spot, or I think like more on the bottom part, right? And with that, what we expect to have as end result is, let me hide the rest here, is this file. That's the complete CAD model, one single solid, all the information, including the bolts here, right? And I did like 4 to put on the level when I 3D printed. Okay. That's the end result. You can download this mesh file, the complete mesh file, at Sketchfab. Just go there, Marcia's Corner. I will be showing more. That's the CAD complete. If you want to know more, if you want this CAD file, please reach out to me, and then I can discuss to transfer the CAD for you. If not, there is a mesh available, watertight, you can 3D print, real size, you just need to scale. And then I don't know if you guys still can see myself on the video, but if you can see, I'm showing here the printed part in red color that I did to match the original one. There's everything. I print that in a bamboo X1E red PLA basic filament. Okay, here's where you can find me. Indicate Technologies is where I work. Is where you will find the software, the scanner, printers, everything. We have a big team of people that can help you to find the right tool for your job. And you can download, see the video on Marcy's Corner. I have my own web page, and there you will find my YouTube channel, my Instagram, the Sketchfab link, where you can go and download not only this file but other files, and then also where you can connect with me if you want. Please go there, watch the video. There are all the full steps, and give your join. I will appreciate. Give your like, join to the channel. With that, Guy, I think that we can open for questions.
Awesome. Thank you, Marcio. That was a great walkthrough. It's great to see the 3D printed part at the end as well. As Marcio said, if you've got any questions, please feel free to ask them now. If you think of something after, then obviously feel free to reach out to myself or to Marcio, and we will make sure that you get your questions answered. We have a couple here to start with. How much time did the full scanning and the full reverse engineering process take?
The scanning was about 15 minutes. That's the beauty of the Leo. It's 100% portable, no cables, no computer. Just arrived there with my backpack, put my GoPro, and that take maybe 15, 20 minutes. Do all the reverse engineer, I would say around 20 hours, because I did that when I have like 1 hour available, 2 hours, I work in small steps. If I will pick that from the mesh to the end, probably 15, 17 hours will be done. I work with Lenovo computers, 64 gigabytes of RAM, a good NVIDIA Quadro card, and wasn't a big thing. Wasn't like I don't need to wait a lot of time for processing.
Awesome. And how big was the scan file? How many points?
The scan file, when was done, was over 20 million triangles. I use HD mode to scan on the Leo. For the ones that understand Artec, I use HD to pick more details. I have a philosophy of scan as best as you can and reduce later, because you cannot add things when it's done. But to do that, I reduce for 15 million. But I can check. I think the one that I post on Sketchfab is around 2-3 million. But then was done by the CAD conversion. Is not the original one with holes. That means you have a full watertight model.
Great. And for your reverse engineering process, then, for your 3D printing process, why did you reverse engineer and create a CAD model as opposed to just using the mesh data?
That's a really good question, and more people ask me, telling me that I was crazy in doing this reverse engineer in such organic part. The first reason is I wasn't able to have a full scan and get all the holes. It's impossible to get inside of this area, even on a big part that is 6 feet tall, around 6 feet tall. Then I have holes. I can close these holes or use even inside of Artec, or go for Geomagic Wrap or Design X or Freeform, one of Geomagic amazing products. The reason that I did the reverse engineer was to have a really nice model, show how good is Design X to handle complex geometries better than any other software in the world in such full automatic way. And then I can use this material for learning process and then teaching people. It's something that we do at Indicate. And bring me to this webinar because I did that. That was a good thing. And we also are big rep partners, and we are planning to print a big version of that. And maybe we will print in almost a Lego thing, a puzzle, every single part, and then we can build. That we are discussing with big rep. Then I will need to do it, you know. Now I have this CAD file, and I won't lie, I did a little bit for fun too.
Awesome. Well, I think that is all the questions that we've got in the chat. For everyone that's here, thank you for joining. You will be receiving the recording of this webinar afterwards if you'd like to review or share with friends, colleagues, loved ones. Anyone that's not here, if you review the recording, you will be sent the recording. But I'd like to thank Marcio. Thank you very much for joining. It's great to have guest speakers and to allow you to share your insights with this audience. So really appreciate your time. As Marcio said, if you'd like to learn more, all of his information is on the screen now. And we look forward to seeing you again at another webinar. Thanks, everyone. Have a great day.
Thank you. Have a good day. Bye-bye.